The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're dialing in from, that'll sound about right. Thanks for joining us today. We're going to get going here in about 2 minutes. I've got 10:58 local time here in Cleveland, Ohio. Same time that Jim Vada has down in Cincinnati. Although
That's
his
right.
weather is extremely nicer than what we're experiencing right now, I imagine.
Well, it was better yesterday. Today it's only 60 and a little blustery.
So we had 70 to start the morning out, and it's already dropped about 10 degrees, and the gray clouds are rolling in. So I anticipate a gloomy day.
Yeah, little gloomy.
So for those of you who haven't joined us before, the way we typically kick things off is in the chat room. If you guys could use the question tab to let us know where you're dialing in from, that would be awesome. We've had really great representation over the last several months, and I always get a kick out of seeing where folks are logging in from. So if you don't mind using that question panel to let us know, that would be awesome. I do see Vancouver is back. Cali, Warfield, PA. I'm a PA guy myself, and if I moved my camera to the left or right, you'd see more Penn State and Eagles gear in my office here. Minnesota, Sacramento, Chicago, Stockholm, Sweden. So far, you've got the prize. Kildare, Ireland, Red Hill, UK, Toronto, Glasgow, Scotland. Great representation in the UK today. Awesome. We've got a great partner over there in the UK, Open Reality. So hopefully the Open Reality guys are on, and girls. And really great, frankly, great representation in the EU in general with NetPeppers and TrueCom. Great partners over there, longtime partners of Seven Signal. Welcome to all of you. We've got Russia on the line. Great representation in Russia with Comtech, and Mexico on. We're well represented down there. Also with Sama Wi-Fi, one of our newest partners. So thanks for dialing in, guys. Malaysia, Montana, North Carolina. Wow, great representation. Thanks for throwing that in there, Kay. We're gonna
Malaysia is
go.
new for us, isn't it? I think that might be a first time for that country.
Yeah,
So welcome.
yeah, welcome, and I think that they take the prize today for longest
Yep.
longest distance. And I imagine it's really an inconvenient time over there as well. I don't have my world clock pulled up, but it's got to be pretty late or pretty early, depending on how you want to look at it. So why don't we go ahead and get started? We've got a really great agenda for you today, as we always do. We've got wireless device connectivity 101. And Jim, I can't advance the slides if you don't mind doing that. For some reason, my mouse no longer is doing that for us. But
Yeah,
we're gonna
no problem.
Thanks, buddy. So we're going to talk a lot about endpoints today and the variety of endpoints, and we're going to try and keep it focused to the remote workforce, since I know a lot of us right now working from home, supporting remote employees, but not all of us. And I know based on the registrations that have come in, I know that we've got a lot of essential workers on the line and still have that day-to-day support of endpoints, including web, Zebra and SpectraLink and Vocera badges and other laptops. So we're going to try and keep it relevant to everyone, but we will be focusing a little bit more on the remote workforce and how you can do that. So just a little bit of housekeeping notes before we get started. We won't go into a full product tour today, and we're going to talk mostly about MobileEye, so no Sapphire Eye stuff today. If you do want a full product tour, you can go to go.sevensignal.com/tour, and that'll get you registered for a product tour. We do a product tour every Friday at noon Eastern time. We are going to share a copy of today's slides as a recording. And all of our recordings are posted on YouTube, so you can get access to previous recordings there. We've got a great archive of 101 type stuff, basic network monitoring, troubleshooting, and much, much more. So go to our YouTube channel and get more information there. all access to free access to our archived videos. We do have some special offers, which I'll walk through real quick. If you're not familiar with our product set, I'm going to go into that in a second. For those of you who are, we are offering MobileEye free for 50 days for up to 50 devices for prospects. For more information on that, go to go.sevensignal.com/50 for 50. I'm going to drop the link into the chat so you guys don't have to necessarily write that down. But know that is available for you. We do have some customers on the line as well, and we've got a special offer for our customers who are not MobileEye customers. That's go.sevensignal.com/1000 for 60. So we're giving our customers 1,000 devices for 60 days to help them get through this pandemic situation. So a little bit about Seven Signal, and we'll get to the meat and potatoes of the presentation today. Seven Signal was founded in 2007 in Helsinki, Finland, and moved to the US shortly after. We hit a lot of major milestones on the way, including our 14th patent just last week for roaming management. So we're going to talk a little bit about roaming and what that means. But a lot of what you see from Seven Signal, you're only going to see from Seven Signal on the product side. So I want you to keep that in mind. We crunch a lot of numbers on a daily basis, over 1 billion data points. We measure a lot of different KPIs, not only on the network side, but also on the endpoint side. And we're going to talk about those a little bit today. But we monitor over 5 million wireless devices. We've got 200 customers, 30 partners around the world with homologation in those countries. We're GDPR compliant, so not only do we stay focused on our technology stack, but also privacy is very, very important to us. And we want to make sure that our customers know that that privacy is point number one. So we'll talk a little bit about that as well. But in a nutshell, Seven Signal is here to enable the wireless world, and how we do it and what we're doing is we're finding and fixing Wi-Fi issues for our customers, getting them to the root cause of issues quickly. And since 2007, we've created a complete outside-in enterprise framework that is unique to Seven Signal, and I'll explain what that is in a second. But everything that we do is completely AP and endpoint agnostic. So depending on, it's irrelevant what network tools you're running, whether you're Cisco or Aruba or Extreme or Mist, we work with everyone and we complement those systems. We certainly do not compete with those systems. And we have a full matrix of competitor analysis and how we complement access points. So if you have questions about current tools that you're running, if it's ThousandEyes or you have certain devices that you're running, we can certainly help you with what the vendors are giving you with information versus what Seven Signal does. So we have a lot of tools at our disposal there. Our offerings are completely modular. So depending on what your challenges are, we can present the right solution for you. Some of our customers have more network type issues rather than others that have more device or endpoint type issues. All of our tools are replete with reporting, alerts, and analytics, as you would expect. And what we're looking for are what we call the top 7 Wi-Fi problems. Everything in the world of Wi-Fi bubbles up to one of these problems, regardless of how they present themselves to the end user. All the end user knows is I can't connect or my Wi-Fi is slow. And they always complain, and that's the story that they send to the help desk, or if it escalates to the wireless engineer. But we can help the engineer get to the root cause quickly. Congestion, coverage, interference, roaming issues, adapter driver combination issues, we can help with all of that. How? Because we're running active and passive tests on the network and on the endpoints for things like packet loss, throughput, latency, and jitter, MOS scores, full spectrum analysis, packet capture, things that other products on the market just cannot provide. So I mentioned the outside in. It's important for you to understand the difference between the legacy environment. If you're not a Seven Signal customer, you're relying on your vendors to give you information about a user experience. And now, even more so, you're relying on tools that didn't exist until Seven Signal to get access or visibility into your remote workers. So the device manufacturers, the access point manufacturers give you great detail on top talkers and other great diagnostics, but they don't give you access to the end user because they don't have that outside in view. And that's where Seven Signal comes in. And that's really paramount now, considering a lot of our workforce is working remotely from their home networks. So all those millions of dollars you spend on those expensive networks for your office buildings are now going unutilized because folks are obviously working from home. So what we do is 7Signal lives on the edge, on the devices, up in the rafters with the access points, giving engineers exactly what they're looking for to get to the root cause of Wi-Fi problems quickly and easily. Being able to go back in time and see what's going on on the network, whether that the individual that calls the help desk remembers when the issue was or not, we can all find that information. So we've got two modules here at 7Signal. On the left is our MobileEye, which we're going to spend a lot of time talking about today, in addition to other helpful troubleshooting hints. But MobileEye is the application or endpoint monitoring solution that lives on the device itself. Any Windows, Mac OS, or Android device, completely 100% software based. And those are the 5 challenges that MobileEye looks for: adapter and driver issues, roaming issues, adjacent and co-channel interference issues, coverage, and congestion. A Sapphire Eye on the right is our perfect client that lives up in the rafters with the access points, down on a table, installed on the wall, wherever our customers decide to install that product. And it is software-enabled hardware, delivers a full spectrum analysis with packet capture, and that gets to the root cause of more network-type issues. So network services, wireless LAN configuration, more interference topics because it does have that the spectrum analyzer. So complete differentiation on the two products. They're going after different problems, and we're the only vendor to offer this suite. So with that said, we're going to get on with the show. So we always start this with a little background of our presenters. Today will be no different. Jim, tell us a little bit about yourself and why these folks should listen.
Yeah, thanks, Don. Good to be here. And a little bit about me. So I'm the Director of Global Wi-Fi Solutions here at 7Signal. Mostly work in a sales engineering capacity. I'm a CWNE and also a Cisco CCNP enterprise with core wireless design and wireless implementation specialties. So they just,
a mouthful.
As you can see, Cisco recently simplified all their certifications. But I'm a wireless network engineer by trade and have experience across several different verticals, most recently healthcare, but other verticals as well. You can follow me on Twitter at Jim Vada, VAJDA, and I have a blog that's just about Wi-Fi content. It's framebyframewifi.net.
Thanks, Jim. I'm looking forward to the presentation today.
Yeah, so let's jump in. You know, one of the things that is a challenge for enterprises and for home networks where enterprise devices are operating now is roaming. It often doesn't work very well. A lot of the devices that are coming into enterprises and that remote workers are using are not designed to roam particularly well. They're really consumer-oriented devices that are designed for, you know, a single AP home in mind, and roaming isn't a high priority for those designs. Yet we see enterprises and businesses increasingly flooded with these devices. Sometimes it's called the consumerization of IT, but you know, for us on the technical side, it causes a lot of headaches because these aren't devices necessarily designed to meet enterprise network requirements, but often they're purchased and we just have to make them work. Additionally, you know, specifically around roaming, it's hard to get any visibility into it from the infrastructure, and certainly not the client side. And then with work from home networks, you have no visibility there. And roaming is an increasingly important capability at home where, you know, multi-AP networks are being deployed thanks to, you know, really easy and effective mesh products. Don, I'm sure you have 4 or 5 mesh APs in your palatial estate, right?
I do have 3, only because I have a finished basement up here in Ohio.
There you go. So let's talk about roaming a little bit. So this could be an enterprise network. This could be a home mesh network. And what happens is, as that client, in this case, we've got a phone, as it moves through the physical space from one AP closer to another AP, that client should detect that the signal strength of that new AP is a little bit higher, and the client should decide to roam to that AP. What's important to realize is that that is a client-controlled decision. The decision to move or roam from one AP to the next is made entirely by the client. It's really important that that roaming algorithm that controls that decision making is very highly tuned, and that's hard to do because it's not, those roaming algorithms aren't standardized in the 802.11 standard, and they're not tested by the Wi-Fi Alliance. So it's really up to the device manufacturer to give us clients with effective roaming algorithms. And for consumer devices, that's often not a priority, like we mentioned before. But when Wi-Fi roaming works well, it looks like this. We're roaming at before the signal strength gets too low, while our data rate is still high, and roaming results in just a little bit of packet loss. And for the end user running applications, it's invisible because our network performance has remained good, or at least good enough to sustain and meet the requirements of the applications they're using. But often roaming is problematic, and this is what bad Wi-Fi roaming looks like. So we've got the same phone, well, a different phone, moving through the environment, but as it gets closer to other APs, it's still connected to that first AP it connected to. It's not changing its association to each AP it's getting closer to. And because it's sticking to that first AP, and that's when we would call it a sticky client, its signal strength is getting really low, eventually so low that retries are building up, packet loss is building up, our data rate is really, really suffering. And now that end user becomes aware that the Wi-Fi stinks and their application performance is bad. They're getting timeouts, things aren't working. The Netflix, is buffering. Or, for those remote workers, could be that Citrix session is locking up. They're getting that black screen of death. If they're on a Skype for Business call, audio starts to break up. If they're in the middle of a webinar and this, and they get into this state, it's going to be bad news. And so, that's really hard to get right on home networks, particularly where, us as enterprise network engineers, we've got no say in what goes on there. It's just sort of up to the end user to create and manage their own Wi-Fi network. Usually that's, very cheap, consumer grade, junk Wi-Fi equipment. They'll often, a residential internet connection is usually best effort, and it's not given the same class of service as a business grade internet connection. A home network often doesn't have much of a design. It's sort of plug everything in. If I can load a web page, then the network's done. And of course, there's no QoS, so supporting applications like voice over IP for home networks is a real problem. And more than that, you have no visibility into that. So roaming in the enterprise or at home is a problem that lacks visibility. And also remote workers working on their home networks, we have a visibility problem there too, a big visibility problem. So that's where MobileEye comes in, like Don talked about in our introduction here. MobileEye is that software agent that runs on those endpoints and is collecting Wi-Fi metrics and application performance metrics from anywhere they are on your enterprise network or at home on their own networks. It's vendor neutral, so we've got clients for Windows, macOS, and Android, and it's network neutral, right? It's not just your enterprise network, it's any network that your clients are operating on, which is particularly relevant today. You can deploy it remotely very easily as well. So you can push it out with Windows SCCM or an MDM tool for macOS and Android to get it deployed without having to bring those enterprise endpoints into the office. So let's get into a demo and look at exactly what we can do with some of this. So I'm going to switch over to Firefox. And I got a beach ball and should be good now. Okay. So this is MobileEye. We're looking at a single client here. This is a Windows laptop for a remote worker. And right away, we can see the problems they've encountered for this particular week that they've been working. And I lost my mouse cursor. There it is. And so we can dig right in and see what they've been dealing with. So Wi-Fi problems, we have roaming problems, and this is a really unique capability for MobileEye. Since we're sourcing this data from the client device, it's simple for us to see when there are these differences in signal strength that would indicate we have a sticky client. Looking at the AP itself, it's really hard to see that. So this is very helpful. And there we go. So what we can do is drill into these events, see the details like this one where here's this laptop on a home network, right? Hashtag Momo Go Boom doesn't sound like an enterprise SSID to me, although who knows?
It's not my network, for the record.
I think if you look that up on Instagram, you'll see a lot of cat photos, or maybe horses, I'm not sure. But we've got a low signal strength on this home network, minus 80 dBm. That's low enough to disrupt almost anything. And there's another AP at minus 61 dBm. So we have a roaming issue for this work from home user that has a multi-AP mesh network, and but their client's kind of letting them down and not roaming very well. So this would be a machine to, potentially, and we can browse through these and look at the other roaming issues they've had. But this would be a machine to look a little bit closer at and see if we can potentially update the wireless drivers it's running or change those advanced driver settings that affect roaming aggressiveness. So one of the cool capabilities with MobileEye is we collect all those details about that particular client. So we can see here, not only is it an HP Spectre X360 convertible Windows box, but what's critical to Wi-Fi performance is the adapter and driver. So this guy is lucky to have this brand new Wi-Fi 6 adapter, and this is the driver version for it. So maybe we could go look at Intel's website and see if there's a new driver that might help out the performance here. That's a very cool capability of MobileEye. We can also look at the change history of this machine. So we can see, he started out with the Intel 7265, but on March 3rd, he got that adapter upgrade, and he also installed a driver update a few weeks ago on March 25th. So we can use that to correlate differences in performance, and also to validate that if we're asking a device team to update drivers and adapters, we can verify that the changes we requested were made. So very handy there. So let's look at some other problems that we've seen. So just for that week, we detected 336 coverage problems. So again, we know he's got multiple APs, but maybe he needs another mesh node, because you can see there are instances where his signal strength has gotten pretty low, minus 79 dBm, and he hasn't had any AP to roam to in those circumstances. Again, really unique perspective here, because we're getting that client perspective. So we know what the RSSI is at the client and the RSSI of the surrounding APs, which is really unique to MobileEye. So that's handy. We can go a little bit beyond Wi-Fi and look at congestion problems, certainly with a Wi-Fi component. But this is where the throughput test that we run has a low result. In this case, just below 2 megabits per second. So that's pretty low and could be disruptive depending on the applications you're running. So what was going on? Well, what's really cool is we've got all these other data points to look at. And this kind of reminds me of the quick check that Keith Parsons likes to run when he's evaluating Wi-Fi performance. We've got great signal strength, minus 35 dBm. We're line of sight to that AP for sure. A really healthy data rate. That's the highest data rate you can achieve with a two-stream 802.11ac client with 40 megahertz channel width, I believe. Have to look up mcsindex.net to verify that, but all that data is available there. So anyway, but the Wi-Fi data looks good. Our throughput is low. So what's going on? Well, our channel utilization, right? How much capacity is being used on the channel we're operating on is really low, 3%. So 97% of the time the channel is available, and we've only got 5 clients out there. It's pretty cool that we can pick this up from our agent. What we're doing is getting it from the QBSS load information element and the AP's beacon. But this tells us that we've got a really healthy Wi-Fi connection and there's a available capacity on the channel. So our low throughput problem is probably related to the internet circuit that he has at his home. And this is an increasingly important problem, since who knows what home internet connections your work from home users are using. It's one more factor that's a little bit outside of your control. So that's very, very handy. And we can browse through. We've got another issue here where the throughput was a little bit better, but still below the threshold to be set. And again, channel utilization at 0% right before that test. So not a Wi-Fi problem, something going on with that residential internet connection. Really valuable look at co-channel interference and adjacent channel interference here too. Again, with home networks, you never know, right? If they're in a dense apartment building and everybody's operating on 2.4 gigahertz, there's going to be a ton of CCI. And there could be adjacent channel interference where we have partially overlapping channels. So here we've got instances where he popped into the office at our headquarters, and we're standing up APs in our lab left and right. We've got a bunch of APs in Uni 1 with partially overlapping channels that you can see here. One's on channel 48 with 80 megahertz width, one's on channel 40 with 20 megahertz width, and one is on channel 36 with 40 megahertz channel width. So these are all partially overlapping and causing interference and bad performance with each other. And this is something you definitely see in work from home environments too. So the nice thing about having visibility from your clients into CCI and ACI is that, yeah, you get that in a site survey when you do your initial design, and that's the best way to see it. But this gives it to you on an ongoing basis. So as neighboring networks are standing up APs and changing channels, and that co-channel interference starts to change, you get alerted to that. And similarly, if you're using RRM or another algorithm to adjust your channel plan, on its own, you can keep an eye on it with this and help identify any areas where it didn't do such a great job. You can always go into the analysis pane here too to look at the raw data. So if we want to see our signal strength over time and our data rate, right, which is such a good indicator of Wi-Fi health, we can do that. Along with our roaming history, so we can see where our signal strength is at a minimum and compare that to the best neighboring access point that we're not connected to see if there, may have been a chance to roam to a better AP, like we see right here, -82 at that minimum RSSI and another AP at -62. We capture all the connection info that you expect, so we can see the network or SSID we're connected to, along with location. That's a physical location that we create using the Google Maps API. So if we've got locations defined for you, we can track that way. So you can always kind of browse through this data and see what you need to see. One other thing you can monitor with MobileEye that's really handy is end-to-end connectivity issues with the applications that you use in your enterprise. So you've got these remote workers, they're connected out over a VPN. Who knows what their home Wi-Fi looks like? Who knows what their internet connection looks like? And there's also that question of if your VPN infrastructure can keep up with the sudden uptick in capacity or load. So we run active tests like ping and a web download and throughput tests. And we can point these at whatever endpoint we want. So here we're just looking at the gateway. This is just a good way to validate that we've got layer 3 connectivity through this Wi-Fi connection, which we can't always take for granted. But this is an interesting problem. Now we're pinging a Skype for Business VIP, and you can see that we've had packet loss. So 40% of our pings from this test came back, and the rest got dropped. So that's a significant issue, and probably Wi-Fi is a root cause there, operating in the 2.4 gigahertz band. We can look at latency too, because a lot of applications, particularly VoIP and other real-time applications, are really sensitive to latency. So here we are looking at the round trip time for that same Skype for Business VIP, and we've got half a second of delay. That's really going to be annoying on a VoIP call. You're going to have people talking over each other, and it's going to be problematic. We want that to be below 100 milliseconds whenever possible. Same with a Citrix box. We can make sure that Citrix portal is accessible and latency is good. And we could run a web download test against it as well, just to make sure we can even load that Citrix portal, because those things are not always, we can't always take that for granted. So just like the passive Wi-Fi data we collect, in the analysis area, we can browse through this and see what our, what's our latency to the Skype for Business VIP typically, and see where it gets a little high. And also look at our throughput over time, because it's going to be very variable on these residential connections, and see where it drops off or comes back. So far, we've just been looking at a single machine. And this is a good way just to look at that, remote user that's calling in and complaining, and they're a VIP, and we can't say, no, you're on your home network, right? We got to say, okay, let's dig in and see what we can find. But we also have some really nice reports that let us discover clients and APs that are having issues that we can identify for outreach and remediation proactively. So here we can look at all the Wi-Fi problems we saw before, but sort that list by AP, right? And we can look at this by band. So we're looking at 5 gigahertz. Let's see where the most roaming issues are. It looks like it's our Wadsworth work from home location, and it's with this upstairs mesh AP. So maybe those APs are spaced a little bit too far apart, or for some reason we're having roaming issues. Could also be a client-side issue there too. Coverage issues, we can see where those are. Copley, Ohio, work from home location. Congestion issues, you'll see a lot of these. And we could look at this for the 2.4 gigahertz band as well to see where we're having the most issues. And top of the list is our headquarters. So we have very limited 2.4 gigahertz coverage there because we favor that 5 gigahertz band, of course. So nice to be able to look at those by band to, be able to not have the 5 gigahertz band where we're sensitive to performance, have those problems mixed in with 2.4 where often it's just best effort. So that's a very handy report. Another thing that's useful here is our Wi-Fi report. This is where we can browse through all the SSIDs that users are connecting to. So it's just another way of looking at the same data, but now we're organizing it by SSID, where we can drill in and see, that on my home network, no problems reported. Don, what's your SSID? I can't, I don't recall what it was.
It's CookFi.
CookFi.
I may not be in the
look at
global.
that.
Oh, there it is. Ah.
Yeah. One congestion issue though, just in the last 24 hours, not really too bad. But if, just another way of getting to the same problems and surfacing them and getting you visibility into roaming, which is really valuable in the enterprise, and all these other problems that we have no visibility into for work from home users as well. So very, very handy. So with that, Don, we'll go back to the slides.
Yeah, it sounds good. Thanks.
Yeah, there we go.
Thanks for the demo, Jim. We do appreciate it. I'm going to go to the question pane here in just a second and respond to any questions that you folks have messaged in during the presentation. Happy to get to those. Again, we will share a copy of the presentation. We'll post it to YouTube so you can have future access to that as well. So I won't address those questions just yet. And I did get a couple other locations trickle in. South Africa is one that pops out here initially, but thanks for sending those locations in. Great audience today, very diverse locations. A question here from Paul, does the product evaluate cellular and Wi-Fi connectivity?
Yeah, it's just Wi-Fi only.
From Richard, can the best neighbor BSSID be displayed too?
Yes. So as you drill into those problem events, you'll see it there, and also in the analysis pane. We show that BSSID along with the AP name if we know it.
Another question here. In the demonstration, how does MobileEye know that the user changed devices altogether and that it's not just another family member using another family member's user and device?
Yeah, so MobileEye doesn't follow the user, it just follows the device itself. So we're always looking at a specific device, regardless of who's logged in, when we're looking at that device page. And when we drill in from our reports, we're going to see specific devices as well.
Thanks, Jim. Note here from Matthew. It looks like Matthew's on a trial here at 7 Signal. This is very relevant to the findings this week during our trial here. So Matthew, thanks for that note. And thanks for joining us today.
Yeah, great to hear that.
Yeah. How about, so a question here from Mike, could other users' activity also affect one's throughput?
Absolutely, particularly in work from home situations where You could be upstairs doing a webinar and your kids are downstairs streaming Netflix in 4K. We're all using the same internet pipe. So that throughput can get restricted in that point. And the consumer gear we're using, it's not going to have big buffers and intelligent queuing like we would have in the enterprise. So we could see our application performance start to fall apart a lot faster when that internet link gets saturated. So big yes to that one.
Mm-hmm. Where we're seeing, this is from Matthew, where we are seeing strength of neighboring access points, these might not actually be available to the client though.
That's a good question. So our roaming analysis only takes into account those APs that are advertising the SSID that we're connected to. So it is relevant, BSSIDs.
A couple comments, Jim, about people liking the video. So we might have to keep doing it.
Sounds good.
It's the only way I can show off the haircut my wife gave me. So.
I do my own haircuts. It hasn't really changed much.
It looks great. It looks great, Jim. Okay, so this is a question from Joel. How about RF progression over distance over the water? I don't know how we want to approach that one.
Well, RF propagation is different in different environments. I would suggest, Joel, digging into the CWNA study guide that goes over that really well. Water is interesting, particularly for the 2.4 gigahertz band, because it tends to absorb RF energy in that band. So if you've got a indoor pool like Don has, with hot tubs and all that, and water fountains, next to the stairs and all that.
We have a pool and a pond.
There you go. 2.4 gigahertz is going to be a challenge. So you might need to have an extra AP or two for that, or just use 5 gigahertz instead.
Yeah, and if memory serves, I think Joel emailed us about some issues he was having at the marina where he works. So hopefully that was helpful, Joel. Question from Dimitri here. Will Mobileye installed on an Android device show statistics per AP? I have a user roaming on an R610 network, and someone's APs fail to send M1 frames. So sorry if that's too technical.
No, he's talking about the four-way handshake and having issues on reassociation during roaming. So you can look at the roaming data by AP using those Wi-Fi problems by AP reports that we showed. You can also, from the device page, click on an AP or BSSID and zoom in and see all the client problems that have been discovered and the client data for that AP. We're not looking at the reassociation status when that happens, though, but we would show you if the roam was successful or if it lost its connection.
Question here about how the device is being identified. Is it via MAC address and OUI vendor comparison?
Good question. So we capture the host name, the MAC address, and the IP address of the device, of the devices Mobileye is running on. I think he's asking how the adapter and manufacturer get identified. We're not doing an OUI lookup. We are actually querying the operating system directly to get the specific wireless adapter that's installed. So it's a level of detail that's quite a bit better than what you would just get from an OUI lookup.
Still going through these questions. Thanks, Jim. Let's see if I think a lot of them are tied together. Is it possible somehow to see airframe from the client's perspective? Airtime, excuse me. See airtime from the client perspective, excuse me.
We see channel utilization, so we don't see airtime. Airtime is sort of it's a layer 2 look at the channel capacity, and channel utilization is a layer 1 look at the capacity. So those numbers are usually somewhat related, and channel utilization can be used for many of the same purposes.
Thanks for the question, Dan. If the data you collect in the beacon, if the date you collect in the beacon frames is the software client required for the data collection, or could this be integrated into the gateway instead? Hope I asked that.
I see. Yeah, so yes, our agent's required, and it only runs on those laptops and tablets and phones. We don't have any direct infrastructure integration, so we capture that information from the beacon frame, but we don't get it directly from like a back-end integration with the AP or the WLAN infrastructure.
Thank you. Time for one or two more questions here. We're coming up on time. How much of the available bandwidth is being consumed to establish throughput? Obviously, this will have an impact on the user experience.
Yeah, so our throughput test is a 5-second long test. We're not trying to, for instance, download a file of a specific size and see how long it took. So if you have a bandwidth limited circuit, it will only use the available bandwidth that it has for those 5 seconds and then stop. So we're pretty polite. We're kind of like anything else that starts a connection and is windowing up through the TCP process to get more bandwidth. And then like anything else, our packets are queued at the internet interface. So we share bandwidth with everything else. Now that doesn't mean that if there were a lot of clients running throughput tests all at once, it couldn't be disruptive. So you have control over that. So you have the ability to adjust the interval that throughput test is running. Could be every 5 minutes, could be every hour, whatever makes sense to you. Or you could just disable it, right? If you were concerned that you didn't want to use it, maybe you were on a metered internet connection and certainly don't want to pay to use megabytes for throughput testing. You can just turn that off and rely on our other tests that are really valuable too.
All right, thanks for that question, Matt. And we'll go with Gary for the last question here. And it's a opinion question. Are mesh networks so much better than separate APs?
Well, a mesh network is a network of separate APs. I think perhaps you're asking is it better to run a cable, run twisted pair to your APs instead of using mesh, and it is better. You'll get much better performance that way because those mesh APs are using Wi-Fi for backhaul. Sometimes they're using the same channel that they're providing client access on, and so that reduces the airtime available for client access. Also, that extra wireless link adds latency, and certainly a cable with its shielded outside and kind of dependable gigabit low latency performance is going to be better. But most people aren't interested in rewiring their home to install cabled APs, so that's why mesh systems are more and more common, and they do just fine for the most part in home networks.
All right, thank you, Jim, and thank you, Jim, for the presentation today. Folks, thanks for joining us. We're going to end it at that last question. For those of you who want some more product information, Jim, if you don't mind transitioning to that next slide there, it should be our go.7signal.com/tour. If not, that's okay too. Very easy to remember. And if you can't navigate to it on our website, I am happy to send you that information. So all you need to do is reply to any one of the number of emails you get from me, and we'll get you the information you need. So again, it's go.sevensignal.com/tour. And if you're interested in taking that promotion that we've got with MobileEye, full free access to our MobileEye product, that's go.sevensignal.com/50 for 50. And you can get some great information, very easy to access, up and running in just days, just a quick discovery call with our sales team needed. So we're happy to get you in that free trial. So thanks for joining us today. Enjoy the rest of the week into the weekend. Thanks, everyone.
Thank
See you,
you.
Jim.
See ya.